Hey there, in this video I'm going to talk about Newton's second law of motion, which is force. So to start with, the formula of force, it is force equals to mass times acceleration. Okay, which is F equals to ma. The mass, it is kg. The unit for force, it is Newton, which is a capital N, and the A, it is going to ms square. Okay, so at the same time, weight, it is equals to mass times gravitational acceleration. The unit of weight, it is basically force, which is same as Newton, which is a capital N, and the unit for mass, it is kg, and the gravitational acceleration, which is gravity pull. I will just put here a bracket, gravity pull on our Earth, it is going to be 10 ms square. This gravity pull, it is on our Earth. Okay, so in different planet you will have different gravitational acceleration, but on our Earth it is going to be 10 ms square. But on the moon, the gravitational acceleration is going to be 1.62 ms square if you search it on the Google. So this will be W equals to m times g, but it is the same as force, which is F equals to ma. Usually I will not write W equals to m times g. I will just straight away write F equals to ma, because I know that force, it is equals to weight as well. Force, it is same as weight. Okay, so let me erase this line first, and we will try an example so that you will enhance your understanding on this force thingy. So let's talk about a car first. I will draw a car so that we could visualize it. Let's say the mass of this car, it is 50 kg, which is the mass, which is m equals to 50 kg. And this car, it is traveling at 2 ms square, which is the acceleration, it is going to be 2 ms square. Okay, so if this car is traveling to our east direction, this basically this car, when it is moving, it is exerting a force, and we could calculate the force, which is, we know that the formula of force, it is F equals to ma. Let me just use blue pen. F equals to ma, right? So the mass, which is the m, I just have to sub it in, which is 50 times the a, it is the acceleration of the car, it is going to be 2, and it is going to be 100 newtons. Okay, which means this car, it is exerting 100 newtons of force to our east direction. Okay, but the weight of this car, it is different. Okay, so W equals to m times g. My mass is going to be 50 as well. The g is going to be gravitational acceleration, which is our gravity pull, because we are talking about this car on our Earth, is going to be 10. So it's going to be 500 newtons. Okay, so the weight, it is 500 newtons. So basically this is the answer. Okay, so right now, if you are watching this video and you are sitting on your chair or you are standing on the floor, you are basically exerting a force to your chair or to your floor. So let's say if this is a human, and this human weighs of, the mass of this human, it is going to be 10 kg, and our gravitational acceleration is going to be 10 ms, which is our A or our G. So the weight of this human, it is going to be, the weight of this human is going to be 100 newtons, because m it is going to be 10, our gravitational acceleration is going to be 10 ms as well, 10 ms square. So 10 times 10 is going to be 100 newtons. Okay, so just remember, in physics, if you are talking about weight, or the question is asking what's the weight of an object, weight is basically same as gravity pull, which is our gravitational acceleration. Just remember, if the question is asking you the weight of an object on our earth, you just have to change the A, because F equals to ma, or W equals to ma or mg. Just remember, this G is going to be your gravity pull. Okay, so if the mass of the object is going to be 2 kg, and if on earth, you just have to times 10, it's going to be our 20 newtons. Okay, which means our weight, it is always facing downwards, in the down direction. So in different planet, you will have different gravitational acceleration, right? Okay, so right now this car, it is on moon. Okay, just imagine this car, it is not on earth, it is on the moon. So the gravitational acceleration of the moon, it is gravitational, I will just put G is going to be 1.62. If you search this on Google, it's going to be 1.62. So right now, let's calculate the weight of this car. So weight, it is equals to, mass. The mass, it is still the same in this case, the mass is constant. So 50 times the G, it is going to be 1.62. So I will calculate with my calculator here. So 50 times 1.62 is going to be 81 newtons on the moon. If the weight on earth is going to be 50 times 10, which is 500 newtons. Can you see the difference? So this is the difference between moon and earth. Okay, which means if you have greater gravity pull, you will have more weight. Gravity pull increase. If gravity pull increase, your weight will be increased as well, if you are comparing both cases with same mass. Okay, so that's it for this video. I hope you have understood what I have just explained, and do remember to subscribe to my YouTube channel, and I will see you in the next one. Bye.